So now I'm going to try and explain the centipede. This is by far the hardest thing to kind of explain briefly, but I'll do my best. The centipede, my centipede object I have here is a linked list, and it has centipede nodes, so that there's only ever one centipede on screen. Even when it splits, it's still the same linked list. It's just they become split. So the game knows when this centipede is destroyed that it can move to a next wave. That's how it keeps track of them. The centipede node has a data that is either a head or a body, and just so you don't have to check, I'm not using factories. I just realized that before making this video. I couldn't figure it out, so I'm going to concede those points. I'm just, I guess, making a new centipede head and a new centipede body for every node, and the centipede body and head inherit from a base class centipede part, which has most of the guts of it. It has spawning, all the behaviors, and it's just got all of the things that it needs to work, and the actual head and body are both inheriting from that, but they are very small. Like the body here is just it just does its collision and does some cleanup, and the head is the same. The head is a little bit different because the head, there can be solo heads, so I have that constructor set up a bit differently. But these are small like that, and let's see, so the movement, the communication between the head and the body is contained within the a strategy pattern that I have for the body and the head. They both have a process grid position that they inherit from centipede processing. Yeah, they both have a process grid position and a collision behavior. And the head actually processes when it gets the next grid unit here, and then decides what it's going to do. It's in a nest of ifs here. I didn't do the state machine, so it's messy, but yep, it decides what it's going to do, and then the head, or the body, has the same method, but it via the strategy pattern does it differently. Doesn't decide what it's going to do based on whether it's hit a mushroom or not. It just decides its movements based on the next node in the list, and that's where the list comes in. It accesses the other nodes' movements and rotations via going up a level to the list, which it knows that it's in a list, so it goes up and sees its node, and then goes over a node, and then it gets its information from there. Let's see, update method. Alright. So the update method, I believe those are both in the centipede part here. Well, while I'm here, I'll do the movement part here, the movement collections, because the move is kind of similar to the player movement, where it gets in a vector and a rotation from the movement classes that I'll show you in a second, and the current movement thing to be put in here depends on the process grid position, and Mm. Oh, here's the update. Okay, sorry about that. Yeah, so it calls that move method that you just saw, puts in these movements, and the movement, which is a member variable, is an array of offsets that is given via the process grid position. It only does it every certain number of frames, depending on the speed. And I think the last thing I'll show you is the grid. Where's this? The movements, yes. Okay. And so the movements themselves are just a bunch of arrays here that correspond to left, right, up, left, up, right, down, right. And still, when I wanted to have it not move, and then the smooth rotation is used by changing these rotation offsets based on how fast it's going. So hopefully that was good. I get confused looking at my own Centipede, but I think that's that.